Hi, everybody. This is John with ASC, and hopefully you've been enjoying using Seis Brace and done a lot of Seis Brace calculations. So now I'm going to show you how to generate the reports, and then we're going to go through what's in the reports. So I'm going to start sharing my screen with you guys, and we'll show you how it works. Um, so hopefully you're all now seeing my summary of it. I made 4 sway braces here, and I got a little bit of everything in here to highlight some of the features we have. So if I wanted to create a report with all 4 of these braces, I would put a checkbox in here, or I could even just pick select all. And then those are the ones I'm going to create a report with. And I'm going to choose to create a report in submittals. So I click that. And then our web-based system here, we're going to talk to the internet and we're going to wait for this to go by. So depending upon what browser you're using, it will open up a temp file. I happen to be using Edge and it opens up here. If you use Chrome, it might open up down here, but it generates a temp file. It's a PDF. And the other files we've been using are all cloud-based. This is the one you would probably want to save on your server, on your computer, in your job folder. And I chose to get both calculations and submittals. So we generated a 32-page printout. And you can use all 32 pages, or you can go ahead and select whichever ones you want out of this PDF report. The first page I'm going to go through is kind of a summary, and it has the information that you filled in, all the stuff about the project name and address and contractor, architect. All that information is printed out here. And then we also, whatever reference standard of NFPA 13 you chose to design to, 16, 19, or 22, it will show up here. And then the 4 braces that I generated and kind of a little description of them, an explanation shows up right here. And we do some boilerplate legal stuff that the ASC people want you to know about, some of the assumptions we've made and how we did it. And then starting on page 2, and there'll be 3 and 4 and 5, are the somewhat typical NFPA suggested printouts. And I'm going to dissect one of these, starting with the first one we did, or I did. And let's take a look at it. I'm going to zoom in a little bit. So again, we give you the, which edition of NFPA 13 we're using, or sorry, this was the project name, and I called it 2016 because I was using that. Which edition, what type of brace it is, it's a lateral or a longitudinal, etc. The designation you'd put on your plan. Most people draw a little 2-headed arrow thing and they designate it with something. This was SB-1, and if where located, I said C plans. I did choose UL, so that's some of the boilerplate that I used in my decision-making process. I also said it was going to be attaching to the building structure was I-beam. I was going to use a vertical flange on the steel connection. I'm using an AF720. My thickness of steel, and the load perpendicular beam. These were the questions I answered, and it kind of drove this and also drove the picture we got. Brace information, this is all talking about how strong is this piece of pipe here, and it's 1-inch pipe, 7'0". This is the angle orientation I picked. This is the slenderness ratio, least radius of gyration, and the maximum load. This all comes right out of the NFPA tables for Schedule 40 pipe. And if I didn't tell you before, a little reminder, all of the listings and the list testing at UL for our components and all components in accordance with UL 203A require the use of Schedule 40 pipe. And next one would be fastener information. If I had used a bolt or a concrete or something out of NFPA, that would be called out right here. We'll see that in one of the next printouts. And as far as brace attachments, this is where we talk about the low capacity of our sway brace component. Here's our new AF735 as an example, the AF700 and the AF720. And you can see here is the components, their size, if they have a size associated with them. And then this is a rated load, and that is the rated load which has been reduced based on the angle orientation of 45 through 59. So that does the division as required by NFPA. And also because of the load, it says vertical forces do not need to be addressed. So there are some situations in NFPA when you have rather high seismic forces and very small angles relative to vertical that you have to address net vertical forces. we give you a clear that you don't have to do it here. Also, you remember using the software, we figured out our seismic coefficient C sub P. We here just flat out explain that as seismic coefficient of 0.59 is what is used in our project for the seismic force formula of force FPW is equal to the seismic coefficient times the water flow weight of pipe. In our zone, here's the zone of influence described. My main 4-inch steel, 30-foot spacing between my braces. There's its weight. And then I have 3 branch lines, all typical, and they have multiple sizes. They have some 1 inch, some 1.5 inches, some 2, and those are the pieces in the branch line. Each line is that long, and each one has a rising nipple 2 feet long. And we can take all that. Here's the length. Here's the water flow weight per foot. You multiply those together, you get the total weight. Add all those together, you get 1,456 pounds. You multiply times 115% to get as required by NFPA, to get 1,675 pounds. And then when you multiply 1,675 times 0.59, you get a seismic force of 980 pounds. So remember that 980 pounds, that's our seismic force. So all these components up here have to have a capacity greater than 980 pounds. That's the performance-based system that NFPA requires us to do. Our brace capacity and all of its components exceed the load that we placed upon it. A couple other checks that NFPA requires us to do. One of them is for your main, to make sure that it's not overstressed in between the braces. And NFPA says for Schedule 10 pipe, 4-inch, space 30 foot, the maximum allowed load on a 4-inch is 1,071 pounds, which is less than the 989. So we're good. Last thing I've got here I want to point out is the rise nipple stress calculations. Now, this is not required on every rise nipple. NFPA does have some exceptions, but I like to do it on everyone because I certainly want to make sure that the rise nipples aren't going to be overstressed, aren't going to break, and that after the earthquake, the sprinkler system will still be intact to put out a fire. So 2-inch riser nipple, again, it's called out right here. It's 2 feet long. So 2-inch riser nipple with all that pipe trying to stress it says that there'll be 12,039 pounds of force on that steel, and the steel yield strength is 30,000. So 12,000 is less than 30,000. Riser nipple shouldn't break. We're good to go. So that is kind of what's in every single one of these printouts. And a lot of people like to just extract these single one-page summary printouts and put it right on their plans. And by all means, go ahead and do so. But let's see what else we have in our 32 pages. So I'm going to move on to the next brace. Brace 2. This was the one that was done to concrete. So again, this stuff is the same as was before. AF700. That's its load value. That's it. The AF730 for 3-inch pipe. This is a longitudinal brace. It's good for 943 pounds. My particular structure here was cracked concrete, normal weight 4,000 pound. And here's my NFPA information about the sway brace pipe I used. And because my angle is 60 to 90, you can see the load is increased. The greater the angle from vertical or closer to horizontal, the better the brace is. And then here's the information right out of NFPA 13 for the wedge anchor, a generic wedge anchor at orientation C, which is 60 to 90, and the allowable 636 pounds. That is the appropriate or allowable value for the AF700 with its particular prying factor, which I believe is a 0.91. So if you go look at the NFPA tables for something with a prying factor between 0.8 and 0.9, you'll find out that that's the allowable load. So the prying factor of the AF700 has been taken into consideration when determining which value is allowable here for the fastener. It's a longitudinal, so I just have the main. There's the weight of the pipe, 80 feet, 7.9 pounds a foot, 635. This particular design had a C sub P of 0.5, so 635 at 115% per NFPA gets me to 731. Half of 731 with a little bit of rounding is 363 pounds. And you can see everything here is greater than 363. So here's an example where we had a concrete connection and we had some fastener information, whereas the previous one, which was just using our steel adapter, had no fastener information. The third one that I happened to do an exercise was one for composite wood joist. Some Weyerhaeuser TJI. We've partnered with Weyerhaeuser and Truss Joist, and we've incorporated their details. So this one, where it's a little different, same information is specified for the design, same picture, but we've referenced the Weyerhaeuser details specifically. Here is the load capacity of our AF700 and our O35. That one, this project happens to be using CPVC pipe in this example, and our AF035 is a listed lateral brace for CPVC pipe. So this is one where you actually have the brace type is a lateral as a longitudinal, so that the common way to longitudinally brace CPVC pipe is to have a long run of 80 feet or whatever your long run is, and in the middle of it somewhere you put a short T, and a short little side piece, because no one makes a longitudinal CPVC sway brace fitting. There's just no real good way to grab that pipe without crushing and destroying it because of the strength of the CPVC. So the industry practice is to put a lateral, have it be within 2 feet of a change of direction as allowed by NFPA 13, and then have that lateral act as a longitudinal. And we have that right in our software, and that's what we're doing. So the lateral portion of it is 1 foot. So that's a little part sticking out the side. And then we have 80 longitudinal. So my lateral's actually on that 1 foot. So we'll look at that. So that's the detail we have here. Here's the information about the pipe. And then from the Weyerhaeuser detail, this is, they allow 690 pounds for an orientation H with how I have this configured. Let's go a little bit further. Here's my zone of influence. There's my pipe. And the stress on that 1 footer, which, because that's a main that's being laterally stressed, just like in this sway brace up here was a lateral. We worried about the 4-inch was good for 1,000 pounds, 71. This one is good for 161 pounds. That's based on 20-foot spacing, and that's the shortest table, smallest table in the NFPA standard. And you can see the 77 is less than the 161. So again, our brace is good. On the very next slide, we've incorporated the truss joist detail, how to build your assembly. This is not our detail. This comes from True Truss. We've just incorporated it into our software with their permission. It's a partnership between the two of us. But we have the detail called right out in here, and this tells you exactly how to build it to their joist, and then the loads that we're using is right out of their detail as well. So that's kind of a nice feature. Next, the last one I did was a Z-purling. And this was, we've also figured out some stuff for Z-purling. This is based on empirical testing that we did in our laboratories with the thinnest gauge Z-purling available. So my structure is Z-purling. Here's our fasteners and our components again with the D-rater for the angle. Here's our pipe. Here is our through bolt consideration, and we built and tested an assembly with a square washer on the back, so that has a large bearing surface on that relatively thin Z-purlin. Our testing says that this will not pull out or destroy the Z-purlin at the loads we're allowing. So here's the lateral brace. Here's the Z-purlin assembly. And again, here's the C sub P, 0.528. Here is the zone of influence calculations with the main, the line again with all the parts, the load, the total load when multiplied times the C sub P, the stress on the main again, and the stress on the riser nipples. So there's the kind of 4 simple pages most people would want to put on their plans that explain the 4 braces I have in my design. Next thing in our report we give you is a Appendix A. It's an alternate size brace attachments. Now, our software only supports our products, and you should only ever use our products. Our products are only tested in conjunction with our products, and we only know what our products will do. That being said, we also know other products we make and have in our portfolio. So if we have other products that we make and sell that will also do the job, that will do the job, and you could insert them into the calculations, and we know they would work just fine, we actually have them called out right here. So here's different anchors that could be used. Here's different fittings that could be used. Here's different pipe clamps and swivel attachments. Here is some other parts that can be used. Just a feature that can be handy in these days of supply chain problems and that sort of stuff. Next thing we give you is a nice big blow up of every one of your your sway braces, so you can put this on your plan or have it, use it, whatever you find useful. Here's our typical steel into a joist with a steel adapter, and showing our brand new AF735. And note that we even have an asterisk here, which is going to indicate a note that the nuts have to be broken off as part of the installation process. Here is our longitudinal detail. That was the one to concrete. Here is our one to truss joist with a lateral with our CPVC pipe. And here is our Z-purlin one. So there's the 4 pictures for the 4 braces I had. Next thing we give you is an explanation of how we calculated our C sub P seismic coefficients. And I think from the past videos, you've seen how we utilize 3 different methods, A, B, or C. A is use the simplified assumption table in NFPA 13. B is just flat out enter a value. And C is use the more sophisticated formula from ASCE 7. That's how we drive how the table is created with the very conservative assumptions. And whether you use method A, B, or C, you can see for Seis Brace, for sway brace 1, I use method A. For sway brace 2, I use method B. And for sway braces 3 and 4, I use method C. When you use A, all you ever do is put in an S sub S and use the table to get a corresponding C sub P. B is you just flat out declare a C sub P, so there it is. But in method C, when you use a formula, we allow the user to specify an S sub S, a soil site classification, and then also a height in the building. So for brace C, I imagine that was like a warehouse. It was 45 feet tall, and I had a 13-foot mezzanine in there, and that's why I had those TJIs. And for sway brace 4, which was the Z-purlins, I had a 35-foot average height to the roof, and my connection was at 30 feet. So with that information and the soil site classification, you can then run through this formula. Here is the formula that's right on ASCE 7, and any authority having jurisdiction could go ahead and use the A sub P, R sub P, and I sub P variable values, which are required by ASCE 7, and the adjustable variables that we have here for site class, Z and H, which we ask you on the program, and they could go ahead and plug and chug if they wanted, and they could generate the same C sub P's that we showed there. It's very, very transparent. In addition to these equations, the HA would also have to do a little bit with the site classifications A, B, C, or D, and depending upon what your S sub S value is, you would then use this matrix. So if you had site class D with S sub S greater than 1.25, you would have an F sub A of 1. We come back up here in the previous formula, then you see that you take S sub A times whatever your S sub S times 2/3 to get SDS, and SDS is used in the big master formula out of ASCE 7. And if anyone has other more questions with that, please feel free to reach out to me and we could have an in-depth discussion about it. A little more explanation of the site class and explanation for the HG to review how this looks at. Next thing we provide for you is a bill of materials. And depending upon your quantities, we actually group it together. And this is very helpful for you to do your stock listing or purchasing. This could be added to your stock listing for your whole project. There it is all right there. And then after that, calculations, because I did ask for calculations and submittals, we have bound in the current edition or current submittal for all of the components we used. And in the process, we even filled in, based on that information, we used all that information about address, contractor, project, all that gets filled in here as well for you. So here's our 720 that was used in this first sway brace. Here's our AF700. Here is our more about the AF700, more about the 700. Here is the brand new AF735 multi-size lateral sway brace. Kind of neat. There's a picture of it. Here's the loads of it. Here is the installation method. You can see how you install your main, have your brace pipe also there, and then you come up underneath or overhead, doesn't much matter. Flip these over, tighten them up till it breaks off. What's really unique and exciting about this product is this sway brace pipe right here can be 1 inch or 1.25 inches with this product right out of the box. And you can just simply move this hinge pin from one location to the other, and then this sway brace pipe could be 1.5 inches and 2. So in ordering and buying this part, you buy a 3 inch or 4 inch or 6 inch, and you only have to specify the single size of the main you're bracing, and all 4 different sway brace pipe sizes work with it. And then here's the 730s we used. Nice, there's its cut sheet. And 730. And then here's our lateral sway brace AFO 35, which you do have to specify 2 sizes for that one. And I guess I want to stop back here and point out is that you can see right here for service, it is good for CPVC piping. It is one of the few products out there that is listed for use on CPVC piping. And that should be about the end of it. Oh, I think that here's because I did the Z purlin connection, here is the cut sheet for the AS619. That's our square washer that our testing said you got to put it on the back. So to use our detailer, you got to use that. And that is the end of all 32 pages. So I hope you like what you see, and thank you for using our product. And if you have any questions, please feel free to reach out to me and we'll get you some additional training. Thank you. Bye-bye.